Intrapleural pressure is normally subatmospheric. For inspiration, there is requirement of further fall in inspiratory pressure. Inspiration tidal inspiration is an active process. Active process means there is contraction of the muscle. But normal expiration is a passive process, in that no particular muscle contraction is required. And there are pressure changes in the pleural cavity and expansion of the thorax, and there is creation of negativity. Inspiration. Interpleural pressure at the beginning of inspiration minus 2.5 millimeter of mercury at the base of the lung, normal lung. And during the process of inspiration, it will this value. And this is the value at the end of inspiration. Intrapleural pressure. This is the value. And in response to this, there is fall in the intrapulmonary or alveolar pressure. Alveolar pressure. And air enters into the lungs. Yeah. Air enters into the lung. And it is this type of curve and not exactly in this fashion. Because some amount of work is required to overcome the elastic resistance, viscous resistance and airway resistance. If it would be purely elastic, and then this type of interrupted line would indicate, but it is not. It is to some extent skewed in that sense to overcome. The result is that at the beginning of inspiration, after normal expiration, the amount of air remaining in the lungs is the functional residual capacity, and that is the point of relaxation of the entire thoracic system. Clear? And then inspiration, interpleural pressure, it will fall and it is the tidal respiration to minus 6.0, and during expiration, and it will go back to this original value. You will find this type of figure. It may be asked in the examination. And what is the alveolar pressure? Alveolar pressure you will find in your text, in that is the inspiration and expiration. Expiration. And it is 0 at the level of the functional residual capacity, end of the tidal expiration, and it will go in this way. -1, there is +1, either millimeter of mercury or centimeter of water. There is slight fall in the intraalveolar pressure, and there is entry of air, and at the end of inspiration, it is so, and it is communicating with the air, it is 0 pressure, 0 atmosphere pressure, and it will becomes negative, and air will enter. Air will enter. Suppose it is the volume, then it is air will enter, and air will come back. Inspiration, 500 ml or so. Come. This type of pressure changes may be asked in the examination. In normal respiration, what occurs? Yeah. And what are the muscles involved? Inspiration is an active process. Active process. There must be muscle contraction. Principal muscle is diaphragm. Inspiratory muscle, diaphragm. Diaphragm. And you have all learned this in anatomy department. It is a muscular partition between the thorax and abdomen, and its contraction increases the vertical diameter of the thorax, and to some extent also some flaring, that is a transverse diameter. And it varies from 1.5 in the tidal, and when there is forceful inspiration up to 7 centimeter, this dome shaped structure. And its origin you have learned in the anatomy text. Costal part and crural part mainly. At the bottom of the costal part, at the bottom of the thoracic cage, from the ribs the originate, and crural part from the fibers of the vertebral column to crura. Your anatomy department, have you dissected? Have you seen the diaphragm? And there is a central tendon where there is insertion of these fibers, and over the central tendon remains the heart. Remains the heart. Yeah. And when it contracts, is go down. 75% of the tidal volume is due to this. 75%. And the nerve supply of diaphragm is from, তোমাদের স্মরণে আছে অ্যানাটমি ডিপার্টমেন্টে দেখেছো না এগুলো, কোন নার্ভ সাপ্লাই করে ডায়াফ্রামকে? এটা diaphragm is supplied by phrenic nerves on either side. Cervical 3 to cervical 5. Clear? Cervical 3 to cervical 5. And normally it is 1.5, and if there is inspiration, forceful inspiration, it will go down. And due to this, the abdomen, during inspiration, abdomen will normally, there is a movement of the abdomen. It will go up and down with normal respiration. নিশ্চয়ই তোমরা দেখবে এখন খালি গায়ে অনেক লোক ঘুমাতে থাকে রাস্তাঘাটে আশেপাশে, দেখবে পেটটা উঠছে নামছে, অ্যাবডোমিনাল টাইপ অফ রেসপিরেশন। 75% is this. Cervical 3, 4, 5. 3, 4, 5. Cervical. On either side, in this phrenic nerve. Crural fibers have separate phrenic nerve, but separate actions for the crural fibers and that of the costal fibers, and they insert into the central tendon here, and it is required. Suppose whenever there is vomiting or eructations, there must be relaxation of the crural fibers because they surround the esophagus and they have a pinch cock action. Clear? Esophagus, crural fibers, right side and left side, lumbar vertebra, you can remember, and they surround the esophagus, and when vomiting occurs, then there must be relaxation. At the same time, there is contraction of the costal fibers. So the intra-abdominal pressure will increase and vomiting is possible. And other inspiratory muscle are normally operative. There is the external intercostal. External intercostals on either side, in this direction, downwards and forwards. And when they contract, they will they try to increase the diameter of this diameter, and the sternum is projected upward, and also sternum in front. Anteroposterior diameter will increase. To some extent, lateral diameter, flaring. They are pivoted behind. Ribs are pivoted behind. So whenever there is contraction of these muscles, downwards, forwards, and what occurs? The sternum will be prominent, and there is to some extent flaring. There is some amount of transverse diameter will increase, and most of the remaining part, 25%, is due to mainly external intercostal. They are active. If either of them is operative, then normal respiration is possible. And if there is section above this, then no signal is coming from this, no signal is coming from the brain to the diaphragm, and respiration is labored but possible because external intercostal, they are present. Clear? Excuse me, suppose the external intercostal, they are in the thoracic. So if there is section at this part, then this condition is lethal because both the phrenic nerves and the external intercostal become ineffective. Respiration is not possible. Respiration, it is a voluntary muscle. So signal coming from the brain. So if there is section above 3, then both the phrenic nerve and the external intercostals, they are become ineffective, and artificial respiration can maintain the individual or animal. But if it is below this level, then externally intercostal are not functioning, but the phrenic nerve carrying the information, and the normal respiration is possible. Normal respiration is possible. Normal respiration is possible. Yeah. So either of them, they must operate. They must operate. If the section is such a way that the external intercostal is operating only, and they can also maintain, but it is difficult, to some extent labored. And in this way, normal inspiration is possible. And the expiration is a passive process. In that sense, there is no muscle is required for tidal expiration. And how it occurs? Because there are elastic fibers within the lungs, and the chest wall, thoracic wall, it is also elastic. And normal lungs has a tendency to collapse. And chest wall has a tendency to expand. Recoil in the opposite direction. And at the level of the functional residual capacities, these tendencies are neutralized. And there is negativity within the pleural cavity, normally pleural cavity. And there is a thin layer of pleural fluid within the visceral layer and parietal layer, and they can slide past each other. Lung surface and the pleural surface, parietal pleural surface, they can move easily in this way, slide past, but it is difficult to separate. You have knowledge in the hematology practical class. If they are the weight, both are, they contain water, and two slides, one above another, you can slide it easily, but it is very difficult to separate. Much force is required, and this is also applicable in this case. That is the wall of the lung and this pleura, they can slide past easily, but it is extremely difficult to separate. So interpleural space is a potential space. And there is a negativity. And if there is chest wall becomes open, then the lungs collapses. If there is air accumulating due to spontaneous pneumothorax or due to some bullet injury or stab injury, if one side becomes open, then the lungs will collapse on that side. And this term is called atelectasis, collapse, due to these elastic fibers. On the other hand, if the elastic tissue becomes destroyed, emphysema, they will expand, and there will be barrel-shaped chest. Clear? Now this, and expiration is a passive process. Nature's device is that the minimum energy must be consumed. বোঝা গেল? এই শ্বাস প্রশ্বাস যে আমাদের হচ্ছে, এটা সম্বন্ধে আমাদের অনুভূতি কিছু হয় না। Work done 0.3 to 0.8 kg meter per minute. And even with forceful inspiration or expiration during exercise also, there is much increase in this work. Present to that of the metabolic process, it is less than 3% of the energy consumed. 0.3 to 0.8 kg meter per minute. And you have all passed this higher secondary joint examination. Your knowledge of physics is clear and bright, fresh. You can calculate it and it convert into, you can convert it into joule and then calories. বুঝতে পারছো? এটা নিজেরা চেষ্টা করে দেখবে। And average value is 0.5 kg meter per minute. Total calorie consumption you can know from the knowledge of basal metabolic rate, and when you convert this into the corresponding value, calories you can easily make. ক্যালোরি থেকে পেতে গেলে কি করতে হবে? তোমাদের হায়ার সেকেন্ডারি বই খুলতে হবে, খুলে সেখান থেকে জুলে নেবে, এই ক্যালকুলেশনটা জুলে নেবে। বুঝতে পেরেছো? কেজি তো মাসে রয়েছে, কাজে এটাকে তোমাকে ডাইনে এসে নিতে হবে, নিয়ে তারপর তোমার সেন্টিমিটার সঙ্গে গুণ করে তুমি সেখানে আর্গে পাবে, তারপর সেখান থেকে জুলে নেবে, জুলের সঙ্গে যে ক্যালোরি সম্পর্ক আছে সেটা থেকে বার করে নেবে। দেখবে এটা যদি হয় তাহলে পরে, এবং বেজাল মেটাবলিক রেট যেটা দেওয়া আছে বইতে সেটা থেকেও দেখবে, এবং করলে পরে দেখবে যে 2%-এর বেশি হচ্ছে, সামান্য এনার্জি খরচা হচ্ছে, কিন্তু তাতে আমরা জীবিত রয়েছি। আর নেচার তো মূর্খ নয়, সে জানে যে কিভাবে এই প্রাণীটাকে টিকিয়ে রাখতে হবে। সে যদি শ্বাস নিতে নিতেই যদি মরে যায় তাহলে আর কি হলো তার? এই জন্য হাঁপানি বা যখন হবে, when there is emphysema or asthma or left ventricular failure, when there is respiratory distress, then much more energy is required. এবং ওই সময় বেঁচে থাকায় শ্বাসটাতেই সে মরে যাচ্ছে, তার দ্বারা কোন কাজটা হবে? কিছু পয়সা খরচা ছাড়া আর তার দিয়ে তো কোনো কাজ হবে না। বুঝতে পারছো জিনিসটা? হ্যাঁ, কি যে নেচার সবসময় চাইছে যে একটা লোক তরতাজা থাকুক এবং কাজ করুক। আজকে আমার যদি একটা লেফট ভেন্ট্রিকুলার ফেলিউর হয় তাহলে কি হবে? শ্বাসকষ্ট হবে, এবং আমার এত ওয়ার্কে আমার এই এনার্জি এত খরচা হবে শ্বাসের জন্যই, তো আমাকে দিয়ে কোনোই কাজ হবে না। কিছু পয়সা খরচা ছাড়া আর কোনো কাজেই আমি লাগবো না। যত তাড়াতাড়ি এই সমস্ত লোক বিদায় নেয় ততই পরিবারের পক্ষে, তার পক্ষেও মঙ্গল। বুঝতে পেরেছো? কিন্তু চিকিৎসা ব্যবস্থা এখন অনেক ডেভেলপড হয়েছে এবং ফিরেও আসছে, অনেক বারবার করে যাচ্ছে হাসপাতালে, ভর্তি হচ্ছে, সুস্থ হয়ে চলে আসছে। এটা একটা গুড সাইন। কিন্তু তোমার এটা হচ্ছে বুঝতে হবে ওয়ার্কটা, when maximum, whenever there is maximum effort, taking a deep breath and expiration, then each breath, in that case it is 10 kg meter per breath. 10 kg per breath. But during exercise there is increase in ventilation. In spite of that, only less than 3% of the total energy expenditure is there. বোঝা গেছে জিনিসটা? So nature is intelligent, and so normal expiration is a passive process. যেমন আমরা যদি একটা গুলতিক ছুরি যখন টানবো তখনই আমাদের এনার্জিটা হচ্ছে, যেই আমি ছেড়ে দিচ্ছি তখন সেটা হয়ে যাচ্ছে। And how it is possible? By the elasticity of the cord, and it is the elasticity of the lung that is primarily responsible. There is slight contraction of the inspiratory muscles at the very beginning of the expiration, so that there is some braking effect, not abrupt collapse. There is slight activity of the inspiratory muscles at the beginning of expiration, and it provides some braking action. So it will be smooth and regular. And but forceful expiration is required in many cases, suppose during exercise, and there are some muscles that are responsible for expiration, forceful expiration. And important muscles of expiration are abdominal muscle, and internal intercostal. And this is the external intercostal, and in this way there is the external opposite way, Down and front is external intercostal, and in the opposite way, there is this down and posteriorly, there is the internal intercostal. And when they contract, they bring down the thoracic cage, and the space within the thorax is limited. And another is the abdominal muscles, they contract. Physiologically, whenever there is excessive pressure within the abdomen is required, and abdominal muscles do contract in defecation also. And what occurs? Then intra-abdominal pressure will increase, and this pressure is pushing above the organs, abdominal organs to the thorax. And it is opposite effect of the diaphragm and external intercostal. And much force can be generated. During deep inspiration, the interpleural pressure may go down to minus 30 millimeter mercury. And forceful expiration, suppose it is more than 30 millimeter of mercury or millimeter mercury. Even more than. Forceful expiration, interpleural pressure can develop. And that also, forceful inspiration, other muscles are required. Sternocleidomastoid, scalene muscles, Allenesi muscle, they are required. You will have this discussion in anatomy texts, good anatomy texts, Gray's Anatomy also. They devoted some part for this discussion. And there are also additional expiratory muscles also are there. Latissimus dorsi, serratii also. Details you can have in anatomy texts. In physiology text, it is not much detail, and that is sufficient for our understanding. Now this function of the glottis is there, glottis. Glottis is the space between the vocal cords, and there are adductor and abductor muscles. During normal inspiration, there are some separation between them. The separation to some extent increases on two sides. During expiration, opposite occurs, glottis. And whenever we are eating, swallowing, or gagging, they come together. Adductor muscle come together, so that there is no aspiration. আমরা যখন কোনো খাবার খাচ্ছি, এই সময় কথা বলা উচিত নয়। খেতে খেতে কথা বলা উচিত নয়। চুপচাপ খাওয়া উচিত। তার কারণ হচ্ছে there may be chance of aspiration, and then it may be lethal also. খেতে গিয়ে গলায় আটকে গেল এবং তাতে মৃত্যু হয় অনেকের, অ্যাসপিরেশন হয়, কাফে করোনারি বলে, মাংসের টুকরো আটকে গিয়ে মরে গেল, এরকমও প্রচন্ড শ্বাসকষ্ট। তখন হিমলিক্স ম্যানুভার করতে হয় যাতে তাকে ওইটা যেন বেরিয়ে যায়, হিমলিক্স ম্যানুভার, বুঝতে পারছো? কাজেই আমার তো এখান থেকে দূরে চলে যাচ্ছে কেন? কারণ অসৎ লোকের কাছ থেকে দূরে থাকা সবসময় যুক্তিযুক্ত, বুঝতে পেরেছো? সবাই তোমরা সেটা জানো, এই সমস্ত বাজে লোকের থেকে দূরত্ব বজায় রাখা সব, কিন্তু শিক্ষা থেকে দূরত্বটা বজায় রাখা উচিত। হিমলিক্স ম্যানুভার, এটা তোমরা একটু বই থেকে দেখে নেবে যে কিভাবে, যদি তোমার হায়ার সেকেন্ডারি টেক্সটে থাকে সেটাতেও দেখে নেবে কিভাবে থাকে, বুঝতে পেরেছো? হিমলিক্স ম্যানুভার করে তাকে বাঁচাবে, অ্যাসপিরেশন। So during anesthesia there is every chance of aspiration. Clear? And so it is a protective device. There is this adduction occurs during taking fluid, then adduction occurs. And there are also abductor muscles. abductor muscles, and they contract during inspiration. And they are supplied by there is the vagus nerve, different branches of the vagus nerve. Vagus nerve. And if there is abductor paralysis, then there is stridor, S-T-R-I-D-O-R, stridor, abductor paralysis. There is difficulty during inspiration. On the other hand, if there is adductor paralysis, then it will remain open and aspiration of food and fluid may take place. And it produces inflammation, aspiration pneumonia. Yeah. So this is the function of the glottis. And bronchial tone. And these you can remember, I think you have gone through books and have acquired sufficient knowledge regarding the airways. From the trachea up to the alveolar sac, the number of divisions of the airways is কতবার ডিভিশন হয়? ট্র্যাকিয়া কোন জায়গায় ডিভাইড করে? মেডিস্টেনিয়াম ডিভাইড করে, মেডিস্টেনিয়ামে, হ্যাঁ না? প্রথমে হচ্ছে প্রিন্সিপাল ব্রঙ্কাই, তারপরে সেখান থেকে যাচ্ছে লোবার ব্রঙ্কাই, right side 3, left side 2, and then segmental bronchus 10 or 9, and then lesser bronchi, then bronchiole, terminal bronchiole. There are first 16 generations are conducting zone. First 16 generations are conducting zones, because they are the conduits through which air can enter and exit, and no alveoli in their walls, there is no gaseous exchange. And from the respiratory bronchiole, then there is the alveoli in their walls, alveoli bronchiole, and then the alveolar ducts, alveolar sacs. In this way there is a division, and histological characteristics are also different. And I think you have gone through books and acquired sufficient knowledge. এটা আশা করা যায়, শেখা না শেখাটা সম্পূর্ণ ব্যক্তিগত ব্যাপার। এটাতে কাউকে বললে সে অপমানিত বোধ করতে পারে যে আমাকে অজ্ঞ মনে করছেন, আমি সুযোগ পাইনি, এই তাই পড়তে পারি। হ্যাঁ, আপনি এসব কটুবাক্য বলবেন না, আমরা আরো দূরত্ব বাড়াবো, যেমন আপনার কটুবাক্য শুনতে না হয়। বুঝতে পেরেছ? দুর্জনকে দূর থেকে করি পরিহার, সেটা তোমাদের সবার জ্ঞান আছে, সেটা সেইভাবে পরিহার করছে আমাকে সবাই দেখে মনে হচ্ছে। আজকে অনেক দূরে বসছি, খুব ভালো হয়েছে। Now and after this knowledge you can have some understanding. There is ventilation, minute ventilation, and when ventilation is increased, tidal ventilation, that is the when minute, it is called minute ventilation. What is the value normally? It is the respiratory rate multiplied by the tidal volume. Suppose respiratory rate is 12 per minute and tidal volume into half liter, then it becomes 6 liter per minute. This is the minute ventilation, and it may increase, it may be 30, 40 or more. Maximum voluntary ventilation, an individual maximum inspiration and expiration, maximum breathing capacity or maximum voluntary ventilation, you can remember it is 125 to 170 liter per minute. Maximum voluntary ventilation. In this way. It is difficult to continue more than 15 seconds or so, but you can calculate for the minute. This is the volume, but normally this volume is, it is inspired and expired, this type, and all does not enter into the alveoli. All does not enter into the alveoli. Some remain trapped within this dead space, conducting zone or dead space. And dead space can be divided into two: anatomical dead space and physiological dead space, and they can be measured. Anatomical dead space and physiological dead space. Normally you know that up to the end of the terminal bronchiole, there is no alveoli and it is a conducting zone. Up to 16th generation of the arrows, they branch dichotomously and their lumen goes on narrowing and narrowing, but the number increases and cross-sectional area do increase. Suppose at the level of the alveoli, the cross-sectional area is huge in comparison to that of the trachea. 11,800 centimeters square at the level of the alveoli, cross-sectional area. They are small structures. The number of alveoli within the lungs, তোমাদের পড়েছো না এগুলো, number of alveoli, 300 millions, and it is go on increasing after birth. It go on increasing, and in the adult it is 300 million. Small diameter, and total surface area is 70 meters square, 70 square meter. And so this huge surface over which the diffusion can take place, and there is simple diffusion, physical process, no energy is required. মানে লোকে হাওয়া খাচ্ছে, এই জ্ঞান থেকেই তো বলে যে এর জন্য কোনো হচ্ছে না, কোনো সেলুলার এনার্জি খরচা হচ্ছে না, এত বড় সারফেস আছে, এখান দিয়ে হচ্ছে। 1 liter of blood is present in any time, and within the capillaries, pulmonary capillaries, only 100 ml. বুঝতে পারছো? তাহলে পরে বুঝতে পারছো যে কতখানি কত থিন সেটা। 70 মিটার স্কোয়ার এরিয়াতে যদি 100 ml ছড়িয়ে থাকে তাহলে কি হিসাব করতে পারবে তার কত থিন। And the membrane, alveolar membrane is also very thin. In most cases areas it is 0.5 mm or less. So how quick then be the process of diffusion? And nature is always accurate. Nature is always accurate. Everything is optimum. Now this dead space, you have to consider the case of alveolar ventilation. Minute ventilation of an individual, normal individual, suppose it is 6 liter per minute. And the dead space in a normal individual is 18 pounds expressed in ml. Roughly 150 ml. 150 ml in an adult individual, dead space. And alveolar ventilation is lower than that. Then tidal volume minus this dead space into respiratory rate. Dead space. Respiratory rate, suppose if you take it is a 12 per minute into 500 minus 150, then 12 into 350. এটা কত হয়? 420 হবে না? ml per minute. This is the alveolar ventilation. alveolar ventilation. Yeah. 420. 4200. This is the normal alveolar ventilation. And it is the effective ventilation. That is for the exchange. And you can think that if this total volume remains same, but if this respiratory rate will increase, rapid breathing, and in that case, alveolar ventilation will be less. Alveolar ventilation will be less. Clear? 6 liter per minute. Normally it is 12 into 500 ml. Suppose if it is 30, then it is 200 ml tidal volume. Yeah. So if you think that there will be at a slow rate, then it will increase in normal rate, and if this is this, if the rate increases, total remains same. Only rate increases. Then alveolar ventilation will be, then it is 30 into 200 minus 150. It remains constant, dead space. So it is 30 into 50, 1500. তাহলে এক্ষেত্রে কম হবে, বুঝতে পেরেছ, মানে কম হবে। যদি স্লো ডিপ রেসপিরেশন হয় তাহলে it will increase. So this value is much lower than this value, effective. Now how anatomical dead space, that is the part of the conducting zone, or the part where anatomically there is no alveoli, anatomical dead space. And normally physiological dead space and anatomical dead space is equal. When air goes into the respiratory part, beyond the respiratory bronchiole, and there is gaseous exchange, and it occurs quickly. Anatomical dead space can be measured by nitrogen measurement test. Suppose if an individual from the mid inspiration takes pure oxygen up to the total lung capacity, and then exhales, and each moment the nitrogen concentration is measured, and they are plotted in a graph. What should be the different phases of nitrogen concentration will be there. Single breath nitrogen test. Nitrogen concentration. After that is at the mid inspiration, if the individual is taking after mid inspiration in the air and then inhaling pure oxygen, and up to the total lung capacity, and then gradually exhales from the level of the total lung capacity, it exhales up to the end of the residual volume. So what will occur? Initial part of the air coming from the dead space, it will contain no nitrogen. It should contain no nitrogen. এটা বুঝতে পেরেছো? বোঝার কিছু নেই তো এতে। From mid inspiration, individual is taken pure oxygen, and pure oxygen will push it into the alveoli, and the space, that is the dead space, will be filled with only oxygen, and there will be no nitrogen in that case. And when exhaled slowly, then initial part, it will contain no nitrogen, no nitrogen. But after that, there is some mixing. There is a mixing. One, two, three, and four. These are the phases of nitrogen elimination. Single bed nitrogen test. সবাই হাসছে যে সহজ জিনিস হিসেবে আলোচনা করছে, কি জন্য করছে। কদিন আছি আর সেই আলোচনা করে যে তারপরে তোমরা এগুলো এখন থেকে পড়বে, দেখবে সাবজেক্টটা সহজ মনে হবে। রেসপিরেটরি সিস্টেম, এই যে উত্তর দিতে পারছো না, এটাতে কিছু নেই, এটা 2 দিন পরে উত্তর দিতে পারবে, বুঝতে পেরেছো? সহজ জিনিস। From mid inspiration, individual is taking full oxygen, only pure oxygen. So terminal part of the inspiration, this is oxygen, and when it is exhaled, initial part there is no nitrogen, and then there will be mixing. So middle of this, up to middle of this is the anatomical dead space. This is anatomical dead space. And then phase 3, there is from alveoli it is coming. There is emptying of this dead space, and it is the mixing at the interface. At the interface between the dead space and the alveolar space, and it is the pure alveolar. And you see at this end there is some increase in the nitrogen concentration. And so, and this indicate this closing volume. That is, airways in the dependent part is beginning to close. And in the erect position, the ventilation is not uniform. It is more in some areas and less in other areas. In the basal part, there is more ventilation. In the basal part, there are more ventilation per unit lung tissue. And the non-dependent part, apical part, there is less ventilation. It is a normal phenomenon. It is not uniform. In an erect individual, it is not uniform. 350 ml per breath that enters into the alveoli, and they are not equally distributed. There is some non-uniformity of ventilation, and it is normal. And for this reason, this part there is less diluted, and it indicates this closing of the dependent part, small airways, respiratory bronchioles also. They have no cartilage, they cannot support, so they may compress. And the terminal part of the expiration. And when you will see in the textbooks, you will find that they explained in this way. mainly due to the gravity of this gravity in the erect position. Then this interpleural pressure is different. It is less negative at the base, it is more negative in the top part. Suppose at this apical part it is minus 10 centimeter of water, and at the basal part it is minus 2.5 centimeter of water. And transmural pressure, that is the inside and inside minus outside, is more in the apical part normally. Suppose at the level of the functional residual capacity, and in that case these alveoli are larger and it is smaller. And when an individual taking full inspiration, after mid inspiration taking full inspiration of pure oxygen, then there is stretching of all this. It is the initial stage, and there is deep inspiration. Then what occurs? There is a dilatation of both. Suppose in this case, as it is already stretched, it can take less amount of oxygen, and it is initially it is small, but this intake of pure oxygen is more than in this case. There is a limit, so that its nitrogen is not diluted to that extent than this. So at the time of there is the whenever there is this type of maneuver, that is there is this pressure will going on, interthoracic pressure going on during forced expiration in that case, and in that case then they may close. In this case it becomes positive value. It may positive value. So there is closure of this place. Then it becomes occluded. So in that condition, the air containing more nitrogen, that is less diluted, will coming from. So its closing volume means there is the dependent parts. Airways in the dependent part is beginning to close due to positive pressure, positive interpleural pressure, and air is coming preferably from the non-dependent part, apical part, that have taken up less oxygen, so their nitrogen is less diluted, so their concentration will increase, and this point indicates the closing volume. That is the above the residual volume. Whenever there is then it is the closure of the dependent part, small airways of the dependent part. So it is called closing volume. It is a test of the peripheral airways. Closing volume. So it is the anatomical dead space. This is phase 1, phase 2, phase 3 and phase 4. In phase 1 there is no nitrogen. It is contained only oxygen, and then there is mixing at the interface between the dead space and the alveolar space, and there is a slope of increase. But in this case it is from the alveoli, so it is relatively horizontal or plateau, but there is some upward trend to some extent, and it ends with abrupt increase. That increase, that point indicates the closing volume. The air is dependent by becoming close. Yeah. Closing volume, which is the residual volume. And it is residual volume up to residual volume, closing volume. And this part, half of this part and this part total is the anatomical dead space. Dead space can be calculated, physiological dead space can be calculated by Bode's equation. Bode's equation. Bode's equation. Time is short. Bode's equation. Expired air. Normally, when we are expiring, expired air is a mixture of the dead space air and the alveolar air, pure alveolar air. Pure alveolar air can be sampled for the terminal part of our expired air, 10 ml or so. Otherwise, there is some mixing, gases are always mixing. But the basic concept is that in the expired air is a combination of, that is the inspired air plus alveolar air. Theoretically, if you consider, we are taking air and after tidal inspiration, if we exhale up to the normal expiratory volume or functional residual capacity, the expired air is a combination of the alveolar air plus dead space air. So, its concentration of carbon dioxide and it will be different. And this partial pressure of oxygen, of carbon dioxide into tidal volume is equal to that of the alveolar air, tidal volume minus dead space, into P capital A or small a. Small a, when it is arterial, it means that is the physiological dead space. When it is capital A, it means this anatomical dead space, plus this dead space into PiCO2. PiCO2. From the fractions we can find out concentration depends upon the total amount, fraction of that, and if we multiply it with this Pb minus pH2O and we get this partial pressure. And as this PiCO2 is very low, you can ignore this, you can take this. And in this way, P small a oblique capital A, you can find out the anatomical and physiological dead space. So, tidal volume, if you consider, it is 500 ml per breath, and PCO2 it is 28 millimeter of mercury. Plus is equal to 500 minus dead space into 40 millimeter of mercury. Then you can calculate the dead space. It is a Bode's equation.